Good morning, everyone. My name is Ming Wen, and I'm from Huazhong University of Science and Technology, China. It is my great honor to present our new ideas, that is to boost the performance of automated program repair via leveraging bug-inducing commits. This is a joint work with SOSTECH and Hong Kong University of Science and Technology. Automated program repair has gained huge attention from both industry and academia, and a huge number of APR techniques have been proposed recently, among which search-based APR is the major category. One major and long-standing limitation of search-based APR is the search space explosion problem. The search space is collectively defined by the for space, fixed space, and ingredient space. The for space is usually refined by the photolocalization techniques, and many heuristics have been proposed to refine the fixed space and ingredient space. One of the popular methods is to learn from the big code data. Specifically, researchers propose to learn from how bugs collected from open source projects are frequently being fixed. In this study, we are proposing a new direction to refine the fixed space and ingredient space. The new idea is inspired by our observations that developers are often looking for the information of bug-inducing commits when debugging in practice, as shown in the two examples. Therefore, our key question in this study is that when refining the fixed space and ingredient space, instead of learning from how other bugs from open source projects are frequently being fixed, can we learn how the bug was introduced instead? Specifically, can we search for mutation operators and fixed ingredients from the project's version history, especially from the bug-inducing commits when designing APR techniques? Here we show an example of a real bug of OZ. We extract the mutation operators and fixed ingredients from the bug-inducing commits and fixing commits respectively, and here we can see that they are highly correlated. To further validate our new idea, we performed an empirical study based on the Diffix4J benchmark. Specifically, we recovered the information of bug-inducing commits for 91 out of the 355 bugs. Then we compare the mutation operators and fixed ingredients extracted from the inducing commits and fixing commits of a same bug. We first compared the mutation operators, and from the results we can see that the mutation operators to fix a bug can be inferred either directly or inversely from the associated bug-inducing commits for a substantial of the number of the cases, which ranges from 60.2% to 88% over different projects. Next, we compare the fixed ingredients. As we can see from the results, there are substantial fixed ingredients can be inferred from the bug-inducing commits, especially for those with a few tokens, and there are many involved in inverse actions when leveraged to fix a bug, compared with the ones that introduce it. Based on such observations, we designed a simple heuristic as follows. First, we tried to revert the whole changes together with the associated ingredients involved in the bug-inducing commits. If we cannot repair the bug, we then try to revert a subset of the changes via searching together with the associated ingredients involved in the bug-inducing commits. Here we show the results. In total, 11 bugs can be fully repaired and 1 bug can be partially repaired using our strategy. Among them, 8 bugs have never been reported to be repaired by the existing state-of-the-art APR techniques. Such results indicate that the direction, that is to leverage bug-inducing commits in automated program repair, is promising. We also have two major important next steps. First is that we need to design better techniques to infer the mutation operators. Second is that we need to design more sophisticated rules to infer the fixed ingredients. More details can be found in our paper. Here comes to the end of our presentation, and questions are welcomed.